A binary tree is a data structure in which each node has at most two children, and they are referred to as the left child and right child. It is a hierarchical structure where each node contains a value and pointers to its children. Let's understand the binary tree through an example. This is the binary tree because each node contains at most two children. This is the logical representation of the tree. In this tree, node 1 has two pointers. They are left and right pointer pointing to the left and right node respectively. Node 2 has both nodes, therefore it has two pointers. Node 3, 5 and 6 are the leaf nodes. So all these nodes contain null pointers on both left and right side. Now let us see the properties of the binary tree. In a binary tree, each node has at most two children, a left child and right child. Leaf nodes are nodes with no children, and internal nodes are nodes that have at least one child. Height of a tree is the length of longest path from the root node to a leaf node. For a tree with a single node, the height is 0. Depth of the node is the length of the path from the root node to the node. The depth of the root node is 0. Size of a tree is the total number of the nodes in the tree. Level of node, the number of edges from the root node to the node. The root node is at level 0. Each node in a binary tree can be root of subtree. A subtree consists of a node and all its descendants. As we already know that the height of the tree is defined as the longest path from the root node to the leaf node. The tree which shown here has the height equal to 3. Therefore, the maximum number of nodes at height 3 is equal to 1 plus 2 plus 4 plus 8 is equal to 15. In general, the maximum number of nodes possible at height h is 2 to the power of 0 plus 2 to the power of 1 plus 2 to the power of 2 and so on is equal to 2 to the power of h plus 1 minus 1. The minimum number of nodes possible at height h is equal to h plus 1. If the number of nodes is minimum, then the height of the tree would be maximum. Conversely, if the number of nodes is maximum, then the height of the tree would be minimum. If there are n number of nodes in the binary tree, the minimum height can be computed as n is equal to 2 to the power of h plus minus 1. N is equal to 2 to the power of h plus 1 minus 1. Now take minus 1 on the left side, it will become n plus 1 is equal to 2 to the power of h plus 1. Taking log on both sides, it will become log 2 n plus 1 is equal to log 2 2 to the power of h plus 1. Log 2 is common on both sides, so it will become log 2 n plus 1 is equal to h plus 1. So height is equal to log 2 n plus 1 minus 1. Now let us see the types of binary tree. There are four types of binary tree: full binary tree, complete binary tree, perfect binary tree, degenerate binary tree, and balanced binary tree. Let us see the first one, that is full binary tree. The full binary tree is also called as proper binary tree or strict binary tree. The term full binary tree, proper binary tree, and strict binary tree are often used interchangeably, but they can have slightly different interpretation depending on the context. We can see the clarification here. Full binary tree is a tree in which every node has either 0 or 2 children. No node has only one child. Properties: all internal nodes have exactly two children. All leaves are at the same level or depth. Let us see what is proper binary tree. This is often used as the synonym for the full binary tree, where every node has either 0 or 2 children. However, in some contexts, proper may be used to describe a tree where all non-leaf nodes have exactly two children and the leaves are at the same level. Properties: every node has 0 or 2 children. Leaves may not necessarily be at the same level. It depends on the definition used. Strict binary tree. This term is sometimes used interchangeably with the full binary tree but can also refer to a binary tree where all nodes have either 0 or 2 children with strict adherence to the binary structure. Properties: every node must have either 0 or exactly 2 children. This structure is same as that of full binary tree. In summary, we can say that in full binary, all internal nodes have exactly two children, leaves are at the same level. Proper binary tree is typically used to describe a binary tree where all nodes have either 0 or 2 children, though definition may vary. Strict binary tree often used as the synonym for a full binary tree, indicating that every node has either 0 or 2 children. In most contexts, these terms are used interchangeably, but it's essential to clarify the definition if you encounter them in different contexts or sources. Let us see the complete binary tree. A complete binary tree is a type of binary tree in which all levels are fully filled except possibly for the last level. which is filled from the left to right. Here is a diagram to illustrate a complete binary tree. The root node 1 is at level 0, nodes 2 and 3 are at level 1, nodes 4, 5, 6 and 7 are at level 2, nodes 8 and 9 are at level 3. In a complete binary tree, all levels except the last are completely filled. In the last level, nodes are filled from left to right. This tree is complete because every level above the last is fully populated. The last level is filled from the left up to a point, and there are no gaps on the left side. Next is perfect binary tree. A perfect binary tree is a type of binary tree in which all internal nodes have exactly two children, and all leaf nodes are at the same level. Here is a diagram to illustrate a perfect binary tree. Root node 1 is at level 0, nodes 2 and 3 are at level 1, nodes 4, 5, 6 and 7 are at level 2. In a perfect binary tree, every non-leaf node has exactly two children. All leaf nodes are at the same depth or level. All nodes are fully filled at every level. A perfect binary tree is also a complete binary tree, but not all complete binary trees are perfect. Degenerate binary tree. A degenerate or a pathological binary tree is a tree in which each parent node has only one child. This structure effectively becomes a linked list because each node has exactly one child. Here is a diagram to illustrate a degenerate binary tree. Each node in the tree has only one child, making the tree effectively a straight line. This tree can be considered as a special case of binary tree where each node has at most one child, either left or right, creating a structure similar to a linked list. In a degenerate binary tree, the height of the tree is equal to the number of nodes minus 1. In this case, it is 4. The tree is not balanced or complete as it lacks branching at every level. Balanced binary tree. It is a type of binary tree in which height of the two child subtrees of every node differs by no more than 1. This ensures that the tree remains approximately balanced, optimizing operations like insertion, deletion, and search. Types of balanced binary trees are AVL tree, red-black tree, and B tree. Here is the diagram of balanced binary tree. Root node is 4. Nodes 2 and 6 are at level 1. Nodes 1, 3, 5 and 7 are at level 2. In this balanced binary tree, the height difference between the left and right subtrees of every node is no more than 1. Operations like insertion, deletion and search are efficient due to the balanced nature of the tree. The key property of a balanced binary tree is to maintain efficient performance for operations by ensuring that the tree does not become skewed or unbalanced.